And welcome Balaji Rao. So he gonna tell us about his talk, and I'll just give him microphone.
Hello, I hope you can hear me well. This is some work I did jointly with Kirilo himself. Okay, before I start talking, I want to do something a bit different. This talk is going to be not as heavy as the previous one, so you can relax. Okay, so who knows or who doesn't know about this movie and what happens in the movie? Okay, as much as I expected. So this movie is a 90s movie. It's around, the movie revolves around a bus, which is full of people, but also has an explosive. And the explosive would go off if the bus travels slower than 50. So the challenge is to get people off the bus into another moving bus and to save everyone. And how is it related to today's talk? It's because that's the adventure Kirilo and I have been in the land of Kafka consumers and functional streams. The only difference is we have a time bomb ticking, which is the Akka licensing itself. Okay, so that's the title of the talk, Journey from Alpakka to FS2 Kafka. So these are the things I'm going to be covering today. Okay, so this is the agenda for today. I'm going to briefly introduce the consumer itself and then talk about the seamless switchover, the moving from one bus to the other part, and the Alpakka to FS2 Kafka, the code, the easy parts, and then also the not so easy parts, the things we struggle with. And finally, some conclusions in the end. Okay, let's start with the Kafka consumer. So the Kafka consumer I'm talking about is a very important Kafka consumer, which has to be always on. A lost message in the consumer, a lost message is noticed very publicly in the company and costs us money and leads to unhappy customers. Yeah, so we wanted to, this is one of the things we wanted to change while moving away from Akka. Okay, so I did not want to assume too much for the talk, so I put up a small 2 slides of Kafka 101 just to make sure the terminology that I'm going to use is at least covered. So Kafka is a messaging system for communicating between applications. Kafka organizes data into topics, and topics are partitioned for scalability and durability and stuff like this. And each partition has monotonically increasing number called an offset. And these, you can think of them as slots that hold messages. The other next thing you want to know about Kafka is after you consume a message, you can mark it as committed, like something like a watermark saying you have consumed up to this point. And when subscribing to a topic, you can ask for messages from the latest or the highest committed offset. And the next thing that's important for the talk is a notion of a consumer group. Consumer group is a group of instances, application instances, pods, whatever, JVMs, that cooperate in consuming a topic. So a partition has a unique consumer, but a consumer consumes from multiple partitions. So that's the relationship here. Okay, so let's look at some code now. So this is the consumer stream itself. This is a simplified version to not distract you from what's going on. So the first thing is, it's basically simple: consume from a topic, write to a database, and at the same step, return an offset. And in the next step, if it succeeds, you commit the offset. Okay, so as we all know, the difference between that code and production code is error handling. And so let's sprinkle some error handling and see how it looks. So how the typical pattern you do that one uses to do error handling when processing messages from Kafka is something called retry topics and dead letter queues. So the idea is that you have multiple retry topics. So when you process a message from the main topic, there's a failure, you put it into a retry topic 1, retry topic 2, and so on. And finally, it ends in dead letter queue. And these topics are monitored. So if you get a call at night that you have something in your dead letter topic, it's not good news. And the next step is where it changes related to the last slide. The last slide just did a write to database. This one writes to database, but if the write to database fails, it creates a retry message for publishing to the next topic. And to make all this look good and to make all this look like a streaming pipeline, there are these standard constructs like the flexi flow, which knows how to deal with this compound type, where it produces, if there is anything to produce from the previous step. If not, it just passes the offset to the next stage, which is called a pass-through, and then the offset is committed. If only the previous steps have been successful. Okay, so that was the consumer itself. Now let me describe the situation of seamless switching a bit. Okay, so the seamless switch, the problem. So what do we want? We want zero downtime. We don't want to pause the processing. We don't want to lose messages, and we don't want to do a big switch. We didn't want to develop everything and finally try it out in the end. So we wanted to build incrementally. So right from the start, we designed so that we wanted it to be able to go back and forth between the old consumer and the new consumer so that we can test quickly and without fear. So we did 3 things as part of the solution. One is a new consumer group for the FS2 Kafka. This is so that we can consume messages independently. And idempotent DB updates. Luckily, the DB updates are already mostly idempotent. So we wouldn't have to worry if both consumers were trying to write the same message to the database. And we also wanted to do a 3-way switch from the old consumer to the new consumer, in which for a brief period in the middle, we write from both consumers to the database, just so that we don't lose any messages. Okay, now let's look at some code of how FS2 Kafka looks like and what was the easy part in this journey. Okay, so here you see, so this is going to be the pattern for the next couple of slides. You see there's a line on the top which describes how it looks in Alpakka, and the next how it looks in FS2 Kafka. So this looks straightforward about creating a stream of records. As you can see, the FS2 version has multiple calls, whereas the Alpakka has just one method called committable source. As we'll see later, I mean, this was a source of trouble. Okay, this part looks exactly the same. This is the only one that looks exactly the same. And this is the part which does the optional, if there's anything to produce it, and then pass the pass-through or the offset to the next stage. And this has changed in V3. I mean, when Kirilo and I looked at it briefly, it seemed like this convenience is lost and we have to do something much more complicated in FS2 Kafka V3. This looks straightforward again. Okay, so let's look at this, the type. of write DB or create retry message. So this type encapsulates two things: a bunch of producer records for a producer to produce, and an offset, which is used in the later stage of the pipeline to commit. So both of these types produce a pass-through. The committable offset that you see in both types is the pass-through. The producer itself, the flexi flow that you saw, doesn't do anything with this. It just passes it through. And in FS2 Kafka, there is something called a committable producer record, which looks like it's an alias for the producer records of committable offset, but it was meant to be used only with the transaction producer. So this, just be careful. Okay, now that we figured out how to get the stream running, the next thing to figure out was how do we make sure it stops cleanly. Stopping cleanly is important because we want the consumer to leave the group. If the consumer didn't leave the group during shutdown, the partition wouldn't go to a new pod, and there will be a pause. There will be a pause in processing. And Akka Streams provides something called a kill switch out of the box, which can be used to stop the stream externally, but FS2 didn't seem to. The other option to stop the stream was to interrupt the stream via the IO runtime itself. But shutting down the IO runtime did not have the effect we thought it would. So finally, we had to write our own kill switch stream using signaling ref from FS2, which was quite straightforward enough. And this is how it looks like. So the stream has a method called interrupt when, which takes a signal. And when the value of the signal changes to true, the stream is going to be interrupted. And the signal is stored in an atomic reference, and we call this during shutdown. And since leaving the stream was one of the things we were most concerned about, we wanted to write a test for it. This is not so connected. It doesn't fit the theme of the rest of the talk, but it's an interesting thing I thought more people should know, that you can test Kafka applications using this thing called embedded Kafka, which spins up a Kafka instance on the same JVM. And you can write code that looks like this. You say with running Kafka, and then you do stuff, and then the Kafka is shut down in the end. So we use the admin client, Kafka admin client, to find out if there are any members that are still active in the group. And after we invoke the kill switch, we wait for, I don't know, eventually for it to be empty to make sure that the kill switch actually works. Okay, so those are the easy parts. So now let's move to the more interesting parts, more dramatic parts. And as I said, the thing that distinguishes, or the thing that decides if a piece of code is production grade is the error handling. And that with that comes retries. So Akka Streams provides something called a restart source that provides a way to restart a source. As far as I know, FS2 Streams doesn't have the notion of source, really. I think Akka Streams might be more sophisticated in that it has a graph and things like that. But FS2 Streams is more uniform in its semantics. So restart source, importantly, does not restart the entire stream when there are some failures downstream of the source. So which means, for example, when you try to commit offsets, if there is a failure if the broker is unreachable, restart source is not going to restart your stream. So FS2 doesn't seem to provide a way to do that out of the box. But it seems like one can emulate it using something called handle error width pretty early in the stream. But again, that seemed more complicated and not as straightforward as restart source. So we went with a simple approach using cat's retry. We just restarted the whole stream on error. Okay, it's not ideal, but not too bad either. And when we ran this in production, we saw a lot of retries. I mean, it's good. Okay, the retries worked, but they worked really too well. As in, we saw an unusually high number of retries. And they were all, if most of them, if not all, had this message. It says the offset commit cannot be completed because the consumer is undergoing a rebalance. So for those who don't know, rebalance means the partitions are being moved between different consumers in the group. And there was a helpful suggestion there. It says you can try completing the rebalance by calling poll and then retry the commit. And what we did when these errors happened is we restarted the whole stream, which means the consumer leaves the group and rejoins the group. So each of the steps, right? Leaving the group triggers a rebalance, and joining the group again triggers another rebalance. So this led to a vicious cycle of restarts and rebalances. So it took a long time to stabilize. We weren't really sure why that was happening. So I have a little graphic here to show this. So this is a vicious, I call it the vicious cycle. The commit offset fails due to an ongoing rebalance. And to mitigate that, or to overcome that, you restart the stream, which causes another rebalance, which makes other consumers die trying to commit offsets, and this whole avalanche of rebalances. Now, the next attempt to fix this was, we wondered if we could restart the stream without leaving the group. Now, that would be really good. And it seems like you could just do that. So if you look at the code, the Kafka consumer provides a resource API. So you acquire the consumer once and put the retry logic inside that. And inside the retry logic, inside the code that's covered with retry, you do consumer.records. So the idea is that if anything fails, you'll call consumer.records again, and you have a new stream, right? Everything is good. So this fixed the rebalance problem, and we thought it's all good now, but it brought something much worse. We lost a few messages. So we really broke the commitment we had to not lose any messages. And it turns out that the consumer.records method is supposed to be called only once. And the recommended way is to release the consumer on error and not call records multiple times. This was found in documentation, but not on records. And who reads documentation? I mean, that's why I preferred the Akka API, Alpakka, which you could not do this. You could, every time you called a method that created, every time you called a method to create a stream, it's a different consumer, it's a different stream. You couldn't do something like this. Okay, so we are back to square one. There seems to be no way out of restarting the stream on error. But can we do something else? Can we ignore the rebalance in progress exception that happens when we try to commit offsets? And with some digging, we found out that FS2 Kafka has something called a commit recovery as part of its settings, which can do exactly this, what we want. We can catch rebalance in progress exceptions and kind of ignore them, because the next round of commits is going to work. When digging for this, or when trying to come up with a solution, we actually found out that FS2 Kafka consumer, FS2 Kafka has some code that it detects, or it knows, if it knows that there is a rebalance in progress, it doesn't try to commit. But there is a race condition there that it learns about rebalance only when it calls the poll method. So it may not know it soon enough, so it tries to commit and then it breaks. So luckily this worked, and the FS2 Kafka consumer has been running in production ever since. Okay, so that was it. So I have some nice conclusions. Overall, the endeavor was a success. We learned a lot about cats, FS2 Kafka, and Kafka itself. Kind of as a, I don't know what we're expecting. Maybe we're expecting me to say FS2 Kafka is great. I mean, it is. I think it has a lot of potential, but I think we've still found that Alpakka to be overall more sophisticated. For example, things like you are unable to create multiple streams. And for example, the rebalance in progress exception that I talked about is handled automatically in Alpakka as part of their commit recovery. I don't know why FS2 Kafka doesn't do that. I created an issue on their GitHub asking about that. And then Alpakka Streams provides restartable source, which is of course really easy to use. But I think FS2 Kafka has potential, and that's where we are going. Okay, that was it from me. Thank you.